Thanks, Mike, and thanks for inviting me to speak. It made me feel very special because of my beautiful history at Cornell. And Cornell in New York, and New York growers hold a very special place in my heart. So thank you very much for inviting me. So today we're going to talk about ACC. As Terence just mentioned there, ACC is the active ingredient in Accede. Accede is actually a new apple and stone fruit thinner. I gave a similar talk at the IFTA meeting last month. We talked about ABA and ACC there, but today I'll just talk about ACC. So before we go into the ACC, I'd like to just to brief show you these slides so you understand where ACC actually is placed. So plant hormones and PGRs, plant growth regulators, they regulate several processes in plants. They have several roles, as you can see here in each square, in plant growth and development. The difference between plant hormone and plant regulators is that a plant hormone is hormones are naturally occurring compounds within the plant, while the PGR itself, the plant growth regulators, are either naturally occurring or synthetic produced. So every plant hormone is a PGR, but not every PGR is a plant hormone. We have today about 9 plant hormones that have been discovered, but I added here only the major 5, which is the gibberellins, the cytokinins, the auxins, and the ethylene and abscisic acid. Just get my pointer here. So in general, we could say that within the plant, auxins, gibberellins, and cytokinins are hormones that are promoting, they're inducing growth because of their role on cell division expansion. Of course, if you change the rates, you may be causing another effect to the plant. But then abscisic acid and ethylene, those 2 last ones here, are the hormones that are usually part of the senescence and the maturity process. And of course, also the stress response, for instance, the abscisic acid. But they can have different responses depending on the rate used, or even the phenological stage of the plant when they are applied. If you apply too early, like for instance, NAA, if you apply NAA too early, you are promoting thinning. If you apply close to harvest, actually you are keeping the fruit on the tree, is the opposite effect. So there's different effects. So today we only going to be talking about one class, which is the ethylene. But in fact, we're going to be talking about ACC, which is the precursor of ethylene. So what is ACC then? ACC is the short name and sweet name for 1-aminocyclopropane carboxylic acid. It is the active ingredient in Accede, is a naturally occurring non-protein amino acid present in all plants. It's not considered a plant hormone yet, though there are some papers mentioning that there is ACC is responsible for specific roles in plant, but is not yet considered a plant hormone. And it is, as I said, it is the immediate precursor to ethylene. So when we spray ACC to the plant, it's going to be rapidly converted to ethylene by the ACC oxidase enzyme. But it can also be conjugated in 3 other things in the plant, but we only talk about we are not going to be talking about them because they are of no biological importance. So as I said before, in the first slide I gave, it's a plant hormone that's responsible for plant senescence. Ethylene is a plant hormone responsible for plant senescence and maturation. So what are what ethylene does to the plant then? If ACC is the precursor, so at the end the response is going to be based on the ethylene production. So it triggers ripening senescence, it causes leaf and fruit abscission, increases red coloration. How many of you have sprayed ethephon on apples to get better color? On grapes, ethylene is responsible for increasing red coloration and also induces flowers to form. Terence just mentioned about the summer sprays with ethephon to improve return bloom. So basically what ethylene is actually the plant hormone responsible for that specific factor to improve return bloom. So basically, ACC is the precursor of the ethylene production. I talked about ethephon, but what are the differences between ethephon and ACC? So ACC, as I said before, when you apply to the tree, is rapidly converted into ethylene by ACC oxidase, using the plant's natural biochemical pathways. So actually, when you apply ACC, the plant is going to have the total control on the ethylene production. It's the opposite with ethephon, because when you apply ethephon, actually, basically you are giving ethylene to the plant. So the plant does not have control on the ethylene production. Ethephon is going to degrade and releases ethylene once entering the plant cytoplasm. That's the difference between the two compounds. ACC is a more reliable fruit thinner at higher temperatures. Why I'm saying that? So we did some lab studies. This is back 7 years ago, well, 7 years ago, 3 years ago, 7 years ago, where we studied on cotton, and we actually repeated the same studies this past year. We found the same results. We repeated on apples. But what we did, we sprayed the plants. This is the ethylene level. You know, spray ACC, you're going to increase ethylene production. And here you have the ethylene levels, and here we incubated the plants after spraying into different temperatures, 25 Celsius and 35 Celsius. Which is around, I forgot to convert this, but I think it's 80, both 80, 85. So what happened here? When you spray, I have here my treated control in black, the gray is my ethephon, and the blue is my ACC. So when you spray at 25 Celsius, you have the same amount of ethylene released by the plant. But when you spray at 35 Celsius, you see the amount of ethylene released by ethephon compared to ACC. So the plant actually somehow uses its own biosynthesis pathway, biochemical pathway to kind of control the ethylene production of the plant. So it kind of shuts down. So that's why we say it's a more reliable fruit thinner at higher temperatures. When we talk about stone fruit, if you apply ethephon to stone fruit, you're going to cause gamosis to the tree. So ACC, we have not seen any gamosis in any of the places we have tested. Also, the other difference, which is kind of plus for ACC, is because ACC leaves no residue at harvest. Actually, in the US, APA has granted a tolerance exemption for Accede, because we found that when we spray Accede on the plants, the levels decline back to the background levels very quickly. So you will find, you find ACC in plants anyways, even if you don't apply the chemical. So it's metabolized by the plants very quickly. Ethephon is the opposite, because the problem we have, for instance, ethephon on grapes is because it leaves residue. So growers cannot sell fruit, grapes, for instance, to Europe because of that residue they can find. With ACC, it just degrades very quickly on the environment and within the plant as well. What are the current uses in agriculture? I know Anna and Luis is going to be talking some of the trials they've done, but there are 3 major uses for Accede that we have on the label. Just to make a comment that Terence mentioned about registration, Accede is registered in the US, including New York, but we're not going to be able to sell. We're not selling products the years. You're going to find product to buy only next year. So you guys are going to have full registration. You already have full registration Accede. So it's going to be registered. It is registered for stone fruit thinning. It's going to be the first ever commercial thinning product that's based on a naturally occurring compound. So it's the only product is available for stone fruit. And when I talk of stone fruit, we have the label for peach and nectarines. Apple fruit is going to be one more tool in the toolbox for the growers. It's a more reliable commercial product that we are targeting for late season. And then also we're going to have a label, is not yet on the label, but for some countries, we're going to have the label for grape coloring. It's going to be another partner for Proton, which has the ABA, which promotes coloring. For both stone fruit and apple fruit, it's going to really be a game changer because it's going to help reduce the expense of labor needed for hand thinning, especially now that we have a labor shortage and the labor costs are increasing. And stone fruit is going to be very unique in that case. How is ACC working when we apply? So what is the mode of action for apple and stone fruit? We know the ethylene signaling triggers seed ovule abortion and activation of the abscission zone at the base of the flower or fruit stem. What you're going to see when you apply ACC Accede to the stone fruit, you're going to see start seeing flower drop already 4 or 5 days after applications, and that's they're going to continue to drop for some time. And sometimes now, for instance, now I've been in California helping growers with the grower experience program, and we are seeing in some varieties the flowers are dropping senescing actually on the tree for about 3 weeks after you apply. So it starts 4 or 5 days, but you're still going to see some flower drop, or even if it stays on the hangers on the branch. Plums, we've been doing some plums. We don't have the label yet, but you could see even in 2 days after application, you can see some flowers, and depending if you apply at pinks, at balloon or bud, we call pink bud and peaches, but at popcorn stage, you're going to see some flowers and popcorn flowers already dropping 2 days, within the 2 days. We don't know, I think there's 2 mode of actions here. One is promoting activating the abscission zone, because we see that later, and another one because we see this flower drop on the ground already 4 days, and another one that what is happening, I will believe we're going to find out now, because we're working with some other researchers in Europe to understand more about the gene expression. But we believe that for those flowers that are falling later, maybe there is a effect on the seed, on the ovule. Actually, is aborting the ovules, and then later on the flower is going to drop anyways. And then in apples, what we've seen is not always the case, but we can observe fruit drop as early as 4 or 5 days after application. You're going to see, I'll show you the label. We're going to be applying targeting applications for stone fruit. It's going to be around bloom, and in apples is around the 15, 20 millimeters fruit size. You're going to notice some leaf drop. Even if you apply a bloom, you're going to see some very small leaves. If you see on the video here, you can see some small leaves dropping. It really depends on the variety and on the location and the weather. Actually, we don't see very that often in the stone fruit. That's why we're targeting actually the bloom applications. If you ask me, there is any effect on size? No effect on size. Actually, because we thin earlier, we're getting better size in stone fruit. There is no negative at all, especially because those small leaves, they drop anyways in 2 weeks. They start dropping. And apples, you're going to see some leaf drop. We thought about this difference between varieties, but it depends. It's really, we see some blocks, even with the same variety, some blocks are going to have leaf drop, some blocks you're not going to see leaf drop. We're not seeing a big deal with the leaf drop. So we saw a few blocks this year where we saw a substantial amount of leaf drop, but we're not too concerned at this point, just because of the timing of application. For apples, timing is if you look at the label will allow you to apply Accede it all the way from full bloom to 25 millimeters fruit size. So it has a wide range of, the time is really, it's a large, it's wide here from bloom to 25. Why we done it, I'll show you in the next slide some trials that were done in the US, where actually we compared applications from 8 to 12 and a 20 to 25 millimeter size. And actually the best efficacy within this window here from 8 millimeters is it's most effective at the 15, 20 millimeter size. So that's where we're targeted, because that's where we see more efficacy. If I go to Brazil, Brazil is dropping, in Brazil, we are dropping fruit up to 30 millimeters fruit size in Gala, but we're not seeing that in the US. It's a totally different climate there. We have the label for full bloom, for petal fall, but we don't have any data yet to support applications at that time in the US. We do have data from other countries. And if I look at the efficacy, we're starting doing some full bloom applications now, and we see thinning from full bloom. But when I look at the efficacy of the product when applied from petal fall to 25, I can see that the product, the ACC is most effective at 15, 20 millimeters, and then petal fall, and then 8-12 millimeters. So there is more efficacy here, petal fall, than 8-12. This is the trials we've done in other countries. So we're gonna do trials this year in the US. It's a new effective opportunity for growers. The rates are gonna be from 200 to 400 ppm. Again, as for Maxell and for NAA, we see difference between varieties. Some varieties are respond better than others. So we have to take that into account. This is the work it's from Cornell when I was there in 2017 when we did this work. The graphs is on the left, and that protocol that came from Valent, where here it shows exactly, this is fruit set in the top part here, this is a Gala fruit set, and you compare untreated, and then 200 versus 400 applied at 10 millimeters fruit size, and 200, 400 applied at 80 millimeter size. So the lower the bars here, the more efficacy you get. So it's clear, you can see this clear that is more efficacious at the later stage later than 10 millimeters fruit size. And this is what you see everywhere in every other region as well. And of course, you get a fruit size increase, but it's directly related to thinning activities, not related to the product per se. This is just another, that's when ACC is applied by itself, but our goal here is having ACC in your toolbox. So it started early, started with the bloom application. Terrence talked a lot about that, and then come back with petal fall. And then if you need it later, you can come back with Accede. So this is just to show some data. When Accede was applied early after NAA product at bloom, you don't get too much efficacy at that early stage, and then ACC applied after Maxell applications during the 8-12 millimeters. Then you see more efficacy from Accede at the later stage. So it's gonna be another tool in your box for your thinning program. We had some experiment used program last year in the US, in the entire US. And it was the first time we had we did large plot trials. And we had, for apples, we had a lot of variability in thinning activity from ACC, especially in the East. We saw more thin actually coming from the West last year. And why we're addressing that is because maybe the applications were done too late. It's probably when fruitlets were bigger than 25 millimeters. And what we see is you have to target 15, 20 millimeters fruit size. Unless you have a carbohydrate deficit at that stage, then you can drop the fruitlet. Also, there's a lot of variability in water volume used by the growers, and sometimes even we saw growers going with the 25 gallons per acre. We don't know yet about the translocation efficacy. If we believe that you have to have good coverage for the product, but we're doing studies to confirm that. And as we saw, as I mentioned before, there's difference in thin activity among varieties, not just among varieties, but among years and among blocks. But varieties does play a role here. So the upcoming studies, as I said before, we're doing early applications earlier than 10 millimeters fruit size. We're doing tank mixing, and Terrence is doing some trials as well with combination he showed before. What if a carbaryl gets out and get banned? Then we got an option, tank mixing ACC with Maxell. We're doing Accede with NAA, Accede with Proton. There's several combinations that we're doing. And then also we're looking at other uses as well. For the stone fruit, the label, I'll go quickly. I don't know how much stone fruit, I don't recall having stone fruit in Champlain, but the label is gonna allow, the applications are going from pink bud all the way to petal fall. That's where we're gonna be applying Accede. That's where you see most of the efficacy from the product. The rates are a little bit higher than the apples, 300 to 600 ppm. for peach and nectarines, and then we're working with plums, and plums are more responsive to ACC than peach and nectarines, and then we got to lower the rate for plums. Here, we're gonna see, right as you apply a bloom, you're gonna see some flower senescence. So 2-3 days after applications, you're gonna see the ground full of petals, but that's not really an indication that you got a more or less thinning. Okay, the first effect, don't get confused, because when I was working in California, the growers get very excited about seeing the petal on the ground, but that doesn't mean that you got thinner or not. So you gotta really wait and see the flowers on the ground. So it's a natural process of ethylene getting that in leaf senescence there. This is just to show what I said before. We have an unmet need, especially in the stone fruit, to reduce labor for hand thinning. I'm super excited with the stone fruit part, because I've been working, this is the second year I'm out in California helping, working directly with the growers on large plots. And we got a lot of thinning this year. We didn't get any over thinning on none of the blocks. So it's a really exciting tool for them. And I put a graph here. This is from we see that we need higher rates in California compared to the East, Michigan, Ohio, Pennsylvania, New Jersey, even, and I would include New York here, where we went only with 300s. In California, we probably want to end up with the higher rates for those varieties they have here. There's a lot of varieties. We cannot focus on all of them, but there is differences between varieties, as you can see here. But even though within between varieties and then between place, sometimes one same variety in one place has less thinning than the other. So the weather plays a role here. But in California, where we had on the same block planted at the same time different varieties, you can see the difference between, we get from 5 to 70% thinning. So there is a difference. I wish we could have just one rate for all varieties, but it's not going to happen that way. So this is what I have. I'm happy to take answer any questions you guys have. Thank you.
All right, thank you very much, Polly. We do have a question for you, and I was hoping you could clarify. The person asked, did I hear right that it won't be available for commercial use in 2022? No sales in 2022. Okay, so you were saying it is currently registered in New York.
Yes,
but there won't be commercial sales.
That's correct.
Okay, thank you. And that's pretty much countrywide at this point?
Yes.
Okay, perfect. Thank you.
Mm-hmm.